Okay, let's be honest. When I say the word algebra, what pops into your head? I'm guessing it's late-night homework, right? Confusing problems and always solving for x? But what if I told you that x was just one little letter in a massive, universal language? See, today we're not really doing math. We're going to learn the grammar of reality itself.
So I really want you to chew on this question for a second. What if all those rules, all those symbols you had to memorize weren't just for solving problems on a page? What if they were actually describing the fundamental structure of the universe?
And that's exactly the idea we're digging into today. We're going to see how algebra acts as this grammar for patterns, for balance, for transformation. It's the bridge that takes us from just counting stuff to some really deep, complex reasoning. So we're not just going to look at what these symbols do, we're going to uncover what they truly mean. So, where do we even begin? Well, you start with the basics, right? The fundamental building blocks. Let's call them the atoms of this abstract language. First up, variables. You know, that x or y we all remember? Turns out they're not just placeholders for a number. They represent a really profound idea, fluid identity. They teach us that things in our world are often defined not by what they are in a fixed sense, but by their relationships and their potential to change. It's how algebra breathes dynamism into a world that can sometimes seem pretty static.
So from variables, we start to build our first words. A monomial, a single term like, say, 5x squared, is like an atomic unit. It represents a singular essence, a single indivisible concept. It's the simplest possible idea you can express in this whole language.
But you put two of those atoms together, and boom, you get a binomial. And all of a sudden, we can express something much more complex, duality. Think about it. It could be any two forces pushing against each other, growth versus decay, profit versus loss, input versus output. Algebra literally gives us a syntax for that tension.
And this is where we start building some real complexity. A polynomial, which is really just a sum of these simple terms, lets us model systemic dynamics. Now, each piece of the expression can represent a different force pushing or pulling on a single complex system, like all the different factors that play in an economy or a fragile ecosystem.
Okay, so we have the atoms, but what holds them all together? Let's jump into the next part and look at the invisible architecture, the deep, logical rules that make this language so consistent and so powerful. Let's talk about the rules of this language. Take the commutative property. I mean, knowing that 3 plus 5 is the same as 5 plus 3, it feels super obvious, doesn't it? But what it's really doing is encoding this deep principle of symmetry and reversibility. It means the order you encounter things in doesn't actually change the final outcome. And then there's the associative property, which says that how you group things doesn't matter either. This establishes a kind of structural stability, a sense of equilibrium. You see, these aren't just rules for math, they're rules about how our reality is structured. Now, the distributive property, this one's the ultimate bridge. It's what connects the world of adding to the world of multiplying. It's the tool that lets us take a complex, kind of bundled up idea and carefully unpack it into all its individual parts. Or you can do the reverse, bundle simple parts into a new whole. This is exactly what's meant by the analytical unfolding of complexity. And yes, of course, good old PEMDAS. Please excuse my dear Aunt Sally. We all remember it as this tedious rule, but think of it this way. It's the essential grammar that prevents total logical chaos. It provides discipline within chaos, making sure that no matter who is speaking this language anywhere in the world, we all arrive at the exact same meaning. It's pretty amazing. So, we've got the atoms, and we've got the grammar, but what's it all for? What's the ultimate goal of this language? Well, it's the quest for balance, the quest for a solution. And at the very heart of this quest are the unknowns. There's so much more than just missing numbers. They're the catalysts of inquiry. That X represents potential. It's the frontier between what we already know and what is still waiting to be discovered. It's the question mark that drives the entire process forward. Now check this out. An equation actually works on 3 different levels. On the surface, it's a logical function, right? It's just a statement that two things are equal. But on a conceptual level, that equal sign represents the very idea of balance. And at the deepest level, its map of meaning is a symbolic negotiation, a perfect equilibrium struck between competing forces. And that moment when you finally solve for X, it's so much more than just getting an answer. It's that beautiful flash of insight when a complex, messy statement transforms into a single, crystal-clear piece of knowledge. It's the journey from confusion to clarity. The source material calls this an act of epistemic revelation, a moment of pure discovery.
So how do we actually see this journey? We use graphs. A graph does something that is frankly miraculous. It translates pure abstract logic into a physical shape you can see with your eyes. It creates what you could call the geometry of thought, letting us literally see the relationships we've just been describing.
All right, let's bring this all together. When we step back and look at the entire system, from the tiniest atom to the final elegant graph, a really powerful picture starts to emerge.
What we've seen here is that algebra isn't just a tool you use for calculations. Not at all. It is a formal language, a powerful system for modeling the world all around us. It gives us the structure to describe everything from a single, simple idea to a wildly complex system. And it's all governed by this unwavering, deep logic of balance. I want to leave you with one last kind of mind-bending idea. Think about that simple rule. Anything multiplied by 0 is 0. Seems basic, right? But its deeper meaning is described as an ontological reset. It's a complete return to pure potential, to the void that underlies all of creation. That's the incredible power hidden inside the number 0. It's not just a number, it's a fundamental piece of the hidden grammar of our reality.